Hello. In the previous video, we have discussed about correlation, types of correlation, methods of calculating the correlation, in which we have studied the scatter diagram, Cartesian coefficient of correlation. Now, in this video, we have discussed about displacement rank correlation. Displacement rank correlation coefficient. It is also known as rank correlation, and if we have the data, ordinal data, that means the data according to the orders, and we want to calculate the correlation, we use this Spearman rank correlation coefficient rather than the Cartesian coefficient of correlation, and it is calculated the correlation for the ranks only, and it is dealing with the qualitative characteristics such as like intelligence, duty, honesty, and this Spearman rank correlation of coefficient is given by the Charles Edward Spearman in 1904. This is the formula for calculating the rank correlation, which is 1 minus 6 summation d square divided by n into n square minus 1, where Rs is the Spearman rank correlation coefficient. If we talk about the Cartesian coefficient, Cartesian correlation is denoted by R, and Spearman rank correlation is denoted by Rs. D is the number, is the differences in the ranks between the paired item R1 minus of R2, where R1 is the rank given by the investigator 1 and R2 is the rank given by the investigator 2nd. N is the number of pairs of observations. For example, the ICC ranking of one-day international and test matches for the 9 teams are given here. The test ranks and ODI ranks. Now, if you wanted to check that there is any correlation between the ranks given to the test matches and ODI matches, so we use the Spearman rank correlation, for which we have to calculate the value of D, which is the differences between the rank. So we calculated the differences between the rank. For example, like for the Australia, it is 1 minus of 1 is 0. For India, it is 2 minus of 3, which is minus 1. So similarly, we'll calculate for the all 9 teams. Then we want the value of T square. So what we do, we square the third column. For example, like the 0 square is 0. 1, 1, 3 into 3 is 9. So similarly, we have calculated the D square and taking the sum of this, which is 20. Now, for these values in the formula, as we know that n is what is the number of observations. We have the 90s. So here the value of n is 9 and summation of D square is equals to 20. If we put these values in the formula, we found that the value of R is equals to 0.83 and conclude that there is a high positive correlation between the ranks of ODI and test matches. Now, the merits and demerits of the rank correlation. The merits are like it is easy to compute and understand. It is just, for example, like we here only have one formula, and for which we only have to calculate the value of D. So it is easy to compute and understand. It is highly useful if we have the qualitative data, and when the ranks of the different item values are given, this is the only method for finding the degree of correlation. That means if we have the data like the ordinal, the qualitative, and you want to calculate the correlation, you always use this Spearman rank correlation as compared to the Cartesian coefficient of correlation. Now, the demerits is one of the demerits is we cannot use this Spearman rank correlation for the grouped frequency distribution. And if we have the observations greater than 30, we cannot use the Spearman rank correlation, as it is it becomes cumbersome to calculate the ranks for more than 30 observations. Compared to the Pearson's method, rank correlation is not precise.